All right. So yesterday we just talked about some graphs with the domain and range. What is different about this graph on page 88 than the graphs that we looked at yesterday, Jordan?
Is like
It has what? It has arrows. So yesterday all of the graphs we looked at had endpoints. They had dots at the ends. But this graph has arrows at the end instead. So what do those arrows mean? It keeps going. So this graph is going to keep going. What direction is it going? What other directions? Is it going up?
Yeah.
No, it is going down. What about for the left and right?
Southwest.
No. Is it going left or right? It's very slowly going out. Like this, if it keeps going, it's going to very slowly keep going to the left and very slowly keep going to the right. So this is a little bit different when we talk about the domain and range. For the domain, remember the domain is the x values. So we want to know how far to the left and right this goes. Where does this graph start?
At the 9?
No, for left to right, not up and down.
Oh. 2 and 4.
Well, it goes further out than that.
Oh wait.
-3.
It goes further out than that when you keep going.
-5. I don't know.
It does not have a starting point.
Oh.
Because if it keeps going out, it's going to go to the left forever. It's going very, very slowly, but it is going out forever. It is also going out to the right forever. So is it going to ever have an ending point on the right side? No. So when it goes on forever in both directions, the domain is all real numbers. Yes. So when we write the domain, when it goes on in both directions forever, we say that the domain has all real numbers. Any number you can think of is going to be in the domain. The range. So now we are looking at up and down. Does it have a starting point anywhere?
Yeah, 9.
All right. Is there a high point where it does not go any higher?
9.
9. There's no arrow pointing up. There's nothing that says it's going to go any higher than 9. Is there a low point where it's not going to go any lower?
No.
No, the arrows say that it's going to go down forever. So I can say that the y values, because y is the range, are going to be what? How can we describe that using an inequality?
Y is
Right equals
less than or equal to 9.
Less than or equal to 9.
Wait, if y is like up and down, shouldn't y be all in real numbers?
No, because it's never going to go above 9. This graph stops right here. It's never going to go above 9.
Okay.
If it did go in both directions, then it would be all real numbers. If it was going up and down with an arrow, it would be all real numbers.
Okay. So x is the down and y is the up?
X is side to side. And then y is up and down.
Okay.
Where is the y-intercept? Remember, the y-intercept is where it crosses the y-axis. What is it? 0, 8. So this is the y-axis. The y-intercept is where it intercepts, where it crosses the y-axis. So that would be at the point 0, 8. Are there any relative or absolute minimums? No. Why not, Faith? There's nowhere that there's never any like this is the bottom point, this is the lowest it goes. So there cannot be an absolute minimum or a relative minimum because there's not even any dips in this graph for us to say that there is a minimum. Are there any relative or absolute maximums?
Yes.
What is it?
9.
9. Is that relative or absolute?
Absolute.
Is it also relative?
Yeah.
It's both. So it is both relative and absolute, and that would be at 9. That is the absolute highest that it goes. Yes.
What's the difference between that?
So you can have multiple relative maximums and minimums. Because if we have a graph that looks like this, you can't see that. If we had a graph that looks like this, then all of the high points are going to be relative high maximums. But the only one that's going to be absolute is the very highest one.
Oh, okay.
Okay? All right. Number 2 on the next page. This is the graph of the equation 2x minus 1. Notice the arrows. Again, we have arrows, so it's going up and down, and it's going left and right. So what is the domain?
All real numbers.
All real numbers, because it goes to the left and to the right forever. What about the range?
It's
All real numbers.
All real numbers. It goes up and down forever.
oh,
What is the y-intercept? Where does it cross the y-axis?
0, -1.
0, -1.
what? Oh,
So where it crossed the y-axis, that would be right here. That is the y-intercept. Are there any relative or absolute minimums?
no.
No. There is no low point. Is there any relative or absolute maximum?
No.
No, there's no absolute high point. Is this graph a function?
No.
Okay, yesterday if you weren't here, or for those that were here, we talked about the vertical line test. So I told you to take your pencil and you move it across the graph. If your pencil only touches one point at a time, then it is a function.
1 point at a time.
Yes, so like if it only crosses the line in one place, then it is a function.
If it only crosses the line once.
Yes. If it crosses the line in more than one place at the same time, it is not a function. So yes, this is a function because it passes the vertical line test.
More than one place.
That's not the thing.
No need.
That's not the thing.
Yes.
I thought it was a function of if like the line is like connected.
That makes it continuous.
So if I touch the y and x axis at the same time, then it's not a function?
No, it has nothing to do with the axis. It has to do with the actual thing that's graphed on the graph. So this actual line, if you touched more, so like if you had a graph that looked like this, and you put your pencil through it, it would touch more than one place at a time.
I get
So
it.
that would not be a function. Okay, now we are going to skip to page 92. Alright, so on the top of page 92, we have this graph that is graphed, this equation. F of x equals 3 plus 2x, and they've graphed it for you. And they want to know, what is the domain and range? So first, what is the domain?
All real numbers.
All real numbers. And what is the range?
All real numbers.
All right. So then it goes on to say that in real world situations, not all values make sense for the domain and range. So at the end it says, in such situations, the values that make sense are called the reasonable domain and range. And that's going to be important for all of these word problems and real world problems. So they gave us an example. A taxi ride costs an initial rate of $3, which is charged as soon as you get in the cab, plus $2 for each mile traveled. The cost of traveling X miles is given by this function. What are the reasonable domain and range? So notice it's the same exact function that we had up here at the top. It's still 3 plus 2x. It's the same exact graph. And they've showed you how they got those points by plugging in some x's and finding out what the y is and graphing the ordered pair and connecting them. So first, let's figure out what is the domain for this situation. So we're not really looking at the graph, we're looking at the situation. What is the x value in this situation? What does it stand for?
2.
No, what does it stand for?
Oh, the cost per mile.
What is x? X is not the cost. X is the number of miles. So x is the number of miles. So the domain is the number of miles. So let's think about miles. Can miles be negative?
No.
No. Can miles be positive? Can they be 0?
Yes.
Can you have a fraction or a decimal of a mile?
Yes.
Yes. So it can be anything except negative numbers. So we need to write that as an inequality. How can I write that as an inequality?
X is greater than or equal to 0.
Good. X is greater than or equal to 0. So that's going to include all of the positive numbers, including decimals and fractions.
That's the domain.
That is the domain. The domain can be any number bigger than 0. Then we need to talk about the range. So the y values. What does y stand for in this situation?
The cost.
That is the cost. So this is the range. Can you have a negative cost?
Yeah. If you owe them.
Okay. In this situation, you're in the taxi. It's not going to come out. Your total's not going to come out to negative $5. I'm talking about what is going to actually be on your bill. Your bill would not be negative.
Positive.
So it can only be positive numbers. Does it have to be whole numbers?
No.
No, you can get part of a mile, which would then be part of $1. So again, what would the range be here?
The range? X is greater than or equal to 0. Same thing.
Y is, again,
Y.
y is greater than or equal to 0. So this time we are using y because the range is the y values. So make sure you are using x for domain and y for range. Alright, on the next page, under try these, so now they're not giving us the graph, we're just going to talk about the situation itself. A banquet hall charges $15 per person plus a $100 setup fee. The cost for x people is given by this function, f of x equals 100 plus 15x. What are the reasonable domain and range? So what are the domain values? What are the x values? The number of people. So what kind of values do we need for people?
Whole number.
Whole numbers. What else? And positive numbers. It needs to be whole numbers. And so we're going to say that it's all whole positive numbers. And then we're going to talk about the range. So what values represent the range? What variable?
X.
Y.
Oh.
And what does y stand for in this situation? The cost.
Oh.
So the cost. You plug in the number of people into this function, and it tells you how much it's going to cost. So the cost is the range. So what's the lowest amount of money you could spend if you're paying these people?
115.
What if 0 people show up?
Oh, just 100.
So 100. So it would be y is what?
Y is greater than 100.
Y is greater than or equal to 100.
That'd be a bowling party. It'll be like
8. Y'all go ahead and try B on your own. what is the domain here?
Okay, I'm in.
What do the X, okay, yes. So X stands for hours. So that is the domain. So what is the domain?
X is
Greater than or equal to 0. But there's another restriction on this. It's rounded to what?
The whole numbers?
All numbers.
It's rounded to the nearest whole hour. So the hours are all going to be in here as whole numbers because it says whole hour. So this one's going to be another all whole positive numbers.
Oh, man.
And then the range. So what is the variable for the range?
Y.
Y, which is what?
The cost.
Cost. And what is that going to be?
Y is greater than or equal to 5.
Yes. Because no matter what happens, no matter how many hours, you're just going to pay $5 for the table. So it would be Y is greater than or equal to 5. And then number 2 asks you, are the domain and range of f of x equals 3 plus 2x from item 1 the same as the reasonable domain and range from part A? So what was the domain and range from number 1?
All real numbers.
And remember, it's the same equation and graph for part A, but what was our domain and range there?
all real.
Like all real numbers.
Was it?
All whole positive numbers.
Oh.
No,
What are you talking about? That one?
this one.
X, what is that?
Because this was the right? This is for just the general graph with no situation attached to it. It's all real numbers. But now that we've attached a situation to it, now it's restricted to the reasonable domain and range because now there's a real life situation. So for number 2, that would be no, because in the second example, there was a real world situation in which you need a reasonable domain and range. Number 3 on page 94. I only want to look at part A. First of all, what is the domain of this graph?
0. It's 0, 1, 2, 3, and 4.
Okay, so yes, we are looking at the x values. So where are their dots? There's a dot at 0, 1, 2, 3, and 4. And remember when you put your domain in curly brackets. So 0, 1, 2, 3, and 4. And then the range. So now we're looking at the y values. So that would be what?
1, 3, 5, and 7, and 9.
Right, the y values are 1, 3, 5, 7, and 9.